This is Saxon Advanced Math, lesson 71. This is regarding the ellipse. Now we've got a conical section here we're starting with. We already know that if I were to take a conical section and split it with the horizontal plane that is parallel to either one of the faces of the top and the bottom, I'd end up with a circle. But what if I tilted that plane just a little bit? And as I did so, I would end up with no longer a circle, but an ellipse. Now let's give us some definitions with an ellipse. An ellipse is like a circle that's been elongated. In elementary school, you would have learned that as an oval, right? That would have been an elliptical shape. In science, they're very useful. Ellipses are how orbits of planets work. This is why we get further away from the sun and then closer to the sun, or the moon gets closer to the earth and further away from the earth as it goes in that complete cycle all the way around. And it's not a circular orbit, it's an elliptical orbit. And so ellipses have a little bit different. In a circle, you have a center point. It's the center of the circle. Everything is equidistant from that center. But in an ellipse, you don't. We're going to have focus points. Okay? I've got a focus 1 and a focus 2 in this ellipse. And if I want to think of focus, it's to me, and I know it's not mathematically correct, but I think of a parabola with a focus, and I think of an ellipse almost like two parabolas stretched out facing each other. That's not technically true, but it helps me with the remembering of the different terms. For instance, the focus. So I have the focus. Collectively, they're just the foci. Okay, the two focus points here. Now, these focus, these can be sitting horizontally or vertically, and I didn't show you that on this. We'll see one in just a minute that way. But we also have some other terms we've got to understand. There's a major and a minor axis, okay? So the major is not always horizontal. The longer axis is the major axis, and the shorter axis is the minor axis. If the two axes were the same, we would not have an ellipse, we would have a circle. So when we're looking at the standard form at the origin, now at the origin is very important, and also the standard form like this only works if the ellipse is, the axes for are either vertical or horizontal. They can't be skewed off a little bit one way or the other. But for the standard form of them, and in this book we're going to stay with that, thankfully. We're only going to stay with ellipses being straight up or horizontal. We're not going to work with them at some odd angle. The standard form is x squared over a squared plus y squared over b squared, or x squared over b squared plus y squared over a squared, and they both are set equal to 1. Now, when you look at those two formulas, it's pretty easy to realize they're the same formula with just the a's and b's swapping. And there's a reason for that. By convention, a bunch of people getting together and saying this is how we're going to do it, we're always going to say that the a corresponds with the major axis and the b with the minor axis. Or in a little bit easier terms, the a term always goes with the longer axis. Now, when we do so, and we start realizing this, we'll also know that a is half the overall, so 2 times whatever a is always that major axis length. So, in other words, from here to here would be a, and so from here to here would be 2a, right? There's 2 of them. And from here to here would be b and b, so 2b. And that would be the overall axis length. Now, let's look at example 71.1, and we'll work with this. They say graph x squared over 25 plus y squared over 9 equals 1. Nicely, they put it in the correct format to us. They've already put it equal to 1. They already have a x squared and a y squared term. That's perfect. The a and the b are already on the bottom, and I can automatically identify that this one is going to be bigger than this one because I'm pretty sure 25 is bigger than 9. Therefore, I know that it's going to be using this is my a and this is my b as far as a correlation. They're having you put a 0 in for x on the axis. Right? When you do so, you're going to say 0 over 25 is 0. You multiply both sides by 9, you get 9 equals y squared, so y equals plus or minus 3. Most of you could already say, well, the root of this number squared is going to be the b value, and you're right. You can skip that altogether if you recognize that. I do the same thing for y, and I get plus or minus 5. Now, what that means, I'm going to start at the origin, and I'm going to go up 3, and down 3, right 5, and left 5. So these are the plus and minus, right? And these are a plus and minus 3. So this would be twice the A value, right? Well, twice of 3 is 6. And if I look at that, up 3 and down 3 is a value of 6. This is going to be a value of 10 because it was up 5, or forward 5 and back 5. And that's where these came from. Look at 71.2. 5x squared plus 2y squared equals 15. Now, we pointed out that this formula is very simple to work with when it's around the origin, but there's a couple of things I have to pay attention to. One, I have to always have it equal to the value of 1. So if I look at this, and this is where people get confused, they want to make it much more difficult than it is. How would I get a value of 1? Well, if I wanted a 1 on the right-hand side of this equation, I would divide the whole thing by 15. And I went ahead and did that. I divided everything by 15. When I do so, I'm going to reduce this. 5 over 15 is a 3 on the denominator. 2 over 15 is a 7.5 in the denominator. Now they're stepping up their game a little on this one, and I understand that. They're just saying, hey, it's not always a nice even number, and that equals to 1 because 15 over 15. I am in the correct format. I can label these. I went ahead and jumped. This one, I didn't set them equal to 0. I just went ahead and said, hey, if 3 is whatever something squared is, the root of 3 squared is 3. The root of 7.5 squared is 7.5. So I just rewrote those. And now I know that my A is root of 7.5 and my B is the root of 3. And I can stop and graph, although I don't recognize what root of 3 and root of 7.5 are. So I'm going to use a calculator. And I'm going to say that's about 1.73 and about 2.74. That allows me to sketch this much easier. This is not one that I just put in the calculator. It's actually easier to do it this way than it is to just stick the whole thing in the calculator. So I know that my left and right movement is 1.73. And I know my up and down movement is 2.74. So it's going to go up 2.74 and down 2.74. It's going to go to the right 1.73 and the left 1.73. And you have successfully graphed a vertical ellipse and a horizontal ellipse.